morning. I am Stefano Scorcioni, and I will give to you a brief overview on my activity research. My activity research focuses on the design and optimization of front-end circuits for ultra-low power energy sources. So, first of all, I will give to you the motivation of my research. In the last year, there has been a great effort on the development of a wireless sensor network. Wireless sensor network are a spatial distributed autonomous sensor that monitor physical or environmental conditions like temperature, humidity, pressure, or so on. And find a lot of application in several fields like industrial and logistic field, medical field, and environmental monitoring field. One of the main limitations in the development of a wireless sensor network is the supply of the remote nodes. The easier way to implement the supply of the node is to implement batteries, but batteries have a high cost of implementation and maintenance, and also the battery cannot be used for all the application for their environmental impact. So it is important to try to extend the battery lifetime and possibly to completely replace battery. So to do this, the solutions are several. The first one is to exploit renewable energy sources like solar energy, vibrational energy, radio frequency noise energy, and thermal energy. The second solution is to reduce node power consumption by implementing smart energy saving software and low duty cycle application. And finally, it's very important to develop high efficiency low power management circuits. And my activity research focuses on this last point. In this year, I worked on 3 different projects. The first one is the design and optimization of a low input voltage DC-DC boost converter for micro direct methanol full cell. The second project is the development of a novel architecture RF energy scavenger working at 868 MHz. And finally, the design and implementation of an AC to DC power converter to collect and store the energy produced by a 1 kHz tuned piezoelectric transducer. For brevity, I will describe only the first project. Well, micro fuel cell is devices that converts methanol into electrical energy. They are characterized by a high energy density, but at the same time they provide a few hundred microwatt output power and very low output voltage. And this last 2 points complicate the design of an efficient power management. So the block diagram of the system we develop is reported in the slide. It is composed by differential oscillators that generate the synchronization signals for the entire circuit operation. An intermediate DC-DC boost converter that provides supply voltage for the control logic and the feedback control stage, and the final DC-DC boost converter that provides supply to the remote nodes, and finally the feedback control stage that keep constant the micro fuel cell operating point. So the feedback stage operates in order to maximize the extracted output energy from the fuel cell that occurs with a fuel cell output voltage equal to 300 millivolt. So as shown in the graph on the right, when the load current of the converter increases, the feedback stage decreases the output voltage in order to maintain constant the converter output power, and so also the fuel cell output power. In this slide, I report the implemented DC-DC boost converter and the micro fuel cell realized by the microelectronic department of the University of Barcelona. Some experimental results. In this slide, I report the converter efficiency versus the fuel cell operating point in order to take in account the cell-to-cell variation, for 3 different operating points, the efficiency is reported versus the converter load current. It's important to note how the efficiency is, for most of the cases, up to 60%, and it is a great result because the very low input power available and the very low input voltage available from the full cell. The other 2 activities I worked on is the development of a radio frequency harvester, as shown in the slide that reports the block diagram. It is composed by several branches, each one optimized to work in a well-defined input power level. And finally, an AC to DC power converter for the collection of the energy coming from a 1 kHz tuned piezoelectric transducer for agricultural application. Future work that I will carry out will focus on the test and characterization of the proposed RF energy harvester and the design of an IC piezoelectric transducer as an energy harvester. Thank you for your attention.